So today we are going to discuss on a program, write a program to create a linked list and appending a node. What we are going to do here is we are going to create a node and we are going to append a list to the given things, or we can say that we are going to create a linked list and we are going to append a nodes to that. Before going to this program, let us understand what is a linked list. So what is a linked list? A linked list is a static structure, or we can say a linked list is the linear collection collection of the element linear collection of the data element called as nodes and the linear order linear linear order and the linear order is given by means of the pointer. So what we are going to tell here is the things which we have learned and in the data structures are completely made up of 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 static data members, static static memory allocation static memory allocation, which means that the data which we are going to allocate in a memory, it is non data which are allocated to a memory are known memories itself. Okay, when we are going to work on static, but we have we also have certain things where we need to we need to store certain things we need to store in dynamic memory allocation also, in dynamic memory allocation, because whenever we are going to work on a bigger structure, like say for the example, whenever we are working on a things like where we are not been specified with itself, this much space we require ಆ ತರದೆಲ್ಲ ಇರುವಾಗ ನಾವೇನ್ ಮಾಡಬೇಕು, we should allocate the data in a dynamic memory. So to allocate the data in a dynamic memory, we use of linked list. We use the things called as linked list. So in here, one of the very disadvantages of the given linear lists are in a static structure. What happens here is by using arrays in a static structure, we can't extend the space easily. So whenever we are going to use a static data structure like array, stack, or queues, at the time what happens, we are going to work on a fixed memory and we are not going to able to build spaces, which means that we are going not able to extend the space. So what happens here is at that time we should use some kinds of structures. At that time what we should do here is we should use some kinds of structures which helps us to extend our memory, so this extension is done with the help of dynamic memory location. So linear to overcome the limitations of an static memory or a linear non-linear list, or overcome a development or disadvantage of a static memory like an arrays, this dynamic memory allocation came into picture. So in that very first dynamic memory allocation is called as a linked list. Okay, so what is a linked list? A linked list is Order is a linear collection of a data elements called as nodes, and the linear order is given in the times of in a times of pointer. So pointer is, you already know that it is a address location where we are not going to store a values directly. Instead of storing a values, we are going to store a address directly. Okay, so each nodes contains two parts. One, whenever we are going to use on a linked list, each nodes, whenever you are going to use a linked list, what happens here is each node has two parts. Each node has two parts. Okay, each node has two parts. Each node has two parts. First part here, it is known as data. Two parts. One is data. One, it is data. Second one, it is address. Address of next location. Next. So how a linked list is situated actually? A linked list is situated at the first we have a data, and other one is address or a link of a next location. Okay, the first part contains the information. Whatever the things we need to store in this, we are going to find here. We are going to store some kinds of data or information. The other part consists the address of the next location. So other part, what does the other part consist of? The other part consists of the address of a next location. Okay, so the second part contains the address of the next location. So this is called the address. The whatever the address is which holds, it is called as a link. This is called as a link field. It is called as link field. First above one is called as, this one is called as data field. Data field. And the second one is called as link field. The second one is called as link field. Link field. The first one is called as data field, and second one is called as a link field. So here, whenever we are going to speak on a linked list, we have three different types of linked list. Three different type of linked list. Linked list. The first one is singly linked list. Singly linked list. The second one is double linked list. Doubly linked list. And third one is circular linked list. Linked list. Okay, there are three types of linked list. One is single linked list, second one is doubly linked list, and third one is circular linked list. So what does this do? A single linked list consists of one single data information and one address location to share this address. In a place of data, it is going to store the data, and in a place of link field, it is going to store the link of the next location. So what does the double linked list consist of? The double linked list consists of three places. So double linked list consists of three things. Here, whenever we are going to work on a double linked list, the double linked list consists of three things. One is consists of three things, three parts. One will be address of the previous location, address of previous location, and the data or information, and the third part consists of the address of next location. The third part consists of the address of next location. Third part consists of address of next location. This is how a double A linked list is situated. So double A linked list consists of, it is a linked list in which each node is a point of both next node and also a previous node. So in the middle part, it is going to store the information at the previous next part. It is going to store the address of next location, and in the previous part it is going to store the address of previous location. Okay, so that it has three types. One is back. Here we have three pointers over here. One is back pointer, means it is going to point the field that contains the address of the previous location. Forward means it is going to point the address of the next location. And info contains the information, actual information of the database. The third one is a circular linked list. The third one is circular linked list, in which the last node of the linked list will be connected to the first node of the first node of a single linked list. That is also a single linked list, but what happens here is the last node will have a connection with the single linked list. So these are the three different types of linked list. So whenever we are going to work on a linked list, we have to perform some major operations to work on a linked list. The first one, whenever we are going to work on a linked list, first we should create a linked list create a linked list. The second one, we need to traverse the list. The third one is we need to insert an element to the list. The fourth operation which is going to perform, we need to delete the list. The fifth operation, we can search the element, search the element using the list. The last operation, we can merge the list. These are the different operations which are going to which is performed by using a linked list. Now let us see how to create a linked list and what are the things that are being used in our program called as linked list. To create a linked list, and we need to append a nodes, means we are going to insert a nodes to the given linked list. The first operation here inside the class, first, normally we are going to use the link sections called hash include iostream.h, conio.h, and iomanip.h. Here inside a class, we are going to create in a public sector, we are going to create a linked list, which says that by using a structure, we are going to create a linked list. Here inside this, what we did is struct is a keyword for a structure called as the node. Inside that we have a data and a linked list. How it is means it is like this. We are going to create them like this. We're going to create them. So inside a class, inside a memory, the linked list will be created like this. Here what happens is, inside this data in an integer form, next we have a link called as link. This like this we are going to uh, work, or like this we are going to deal with the We are going to deal with the linked list. The first part here, struct node and in start in data node and link in data node and link. Its name, the structure name is start. So what is the name of the structure? The name of the structure is equals to start. The name of the structure is equals to start. Okay, structure is equals to start. Next, here we are going to create a constructor called as linked list, and but we are not going to define, but we are not going to define, but we are wait a second. So here the struct node in data node star link and star start. This is the part where we are going to create a linked list, and inside the public we have defined first we have defined a constructor, but we are not going we have declared a constructor, but we are not going to define this. This is a class outside class definition. Okay, outside class definition, we are going to declare a structure, or sorry, we are going to define the constructor outside the class, and we have member functions called as print, append and count. We are going to print means we are going to insert a node, how many linked lists are there. Next we are going to append means we are going to insert a linked list, and the count is number of linked lists present in the structure. We are going to count them. The third one is the next part is here we are going to define a here we are going to define a constructor linked list, so scope resolution operator and linked list means, which means that here the scope resolution operator will say the lifetime of this constructor linked list. Here at the when the program starts, when execution starts, your start will point a null operator. The start will point a null operator means what does it mean? Means here the start is always equals to null. The start is always equals to null. The next is void linked list. Next we are going to print, means, which means that I am going to check how many linked lists are there, how many linked lists that I have created in my program, how many linked lists that I have created in my program. So that how to see them. So to see that what we have here is, if the start double equals to null, means what I said, always when a start is equal, when you are going to start a linked list, always your start points to the null pointer. Always your start points to the null pointer. When the start points to the null pointer, which means that the start is equals to null. If the start is equals to null, then we say that the linked list is empty. If the start points to the null, then which means that we say the linked list is empty. Then what we are going to do, we are going to return a linked list. We are going to return a linked list. For example, if we have already have a linked list in our program, we have created a linked list, which means that at that time what does it do? It is going to say the linked list contain, which means that it is going to point a start. It is going to create the start, points the start to temp. If a temp, we are going to create a dummy variable called as temp for a start. If a temp double equals to null, then not equal, which is not equal to null, which means that how many data elements are there, it is going to show you. How many link are there, it is going to show you. So this is how we are going to say, we are going to create a or we are going to print a list present in our database, present in our program. Okay, next, here the second part is for to append or to insert a linked list. So void class name followed by function name which has a data to be passed. Why a data has been required? We have already created a linked list which has data and a link. We have already created a linked list with which has data and a link. Here new node star new node means the name of the node is now new node. So new node is equals to new of node, which is going to here the thing. This is called as a so this is called as a memory allocation, dynamic memory allocation. dynamic memory allocation. So here the new helps to allocate a memory dynamically. The new helps to allocate the memory dynamically. Next, new data is equals to num. New node means the new data. ಇವಾಗ ಈ ನೋಡ್ ಮಾಡಿರ್ತೀವಲ್ವಾ ಆ ನೋಡ್ ಡೇಟಾಗೆ ಒಂದು ನಂಬರ್ನ ಹಾಕ್ತೀವಿ 20 ಅಂತ. ಓಕೆ, ನಂಬರ್ನ ಹಾಕ್ತೀವಿ 20 ಅಂತ ಹಾಕ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ದ null link new node ಹೊಸ ಲಿಂಕ್ ಹೆಸರೇನು null. At the starting there doesn't have any data, so we are going to put null. We're going to put null. Next, if start double equals to null, so ಇದು ಅರ್ಥ ಆಯ್ತಲ್ವಾ. ಸೊ ಹಿಯರ್ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ನ್ಯೂ ಅಂತ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಡೈನಾಮಿಕ್ ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಮಾಡ್ಕೊತೀವಿ. ಅಂಡ್ ಹಿಯರ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟೋರ್ ದಿ ಡೇಟಾ ಅಂಡ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೊವೈಡ್ ದಿ ಲಿಂಕ್ ಟು ದಟ್ ಡೇಟ್ ಟು ದ ಲಿಸ್ಟ್. Okay, next, if the start double if our start is if the start double equals to null, what should happen? The start double equals null ಆಗಿದ್ರೆ start is equals to new node. ಈ ಸ್ಟಾರ್ಟ್ ಅಂತ ಹೇಳೋದನ್ನ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, ನ್ಯೂ ನೋಡ್ ನ ಮಾಡ್ಕೋತೀವಿ, ನ್ಯೂ ನೋಡ್ಗೆ ಹಾಕೋತೀವಿ. ಸಿ ಔಟ್ ದ ಫಸ್ಟ್ ನೋಡ್ ಇಸ್ ಇನ್ಸರ್ಟೆಡ್. ಇಫ್ ದ ಸ್ಟಾರ್ಟ್ ಇಸ್ ನಲ್ ಅಂದ್ರೆ previously your start always becomes a null itself, right? So start double equals null ಅಂದ್ರೆ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ null ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸ್ಟಾರ್ಟ್ null ಇದ್ರೆ ಏನ್ ಹೇಳ್ತೀವಿ, ನಮ್ಮ ಫಸ್ಟ್ ನೋಡ್, your first node is been inserted. Okay, your first node is been inserted. This is how we are going to enter the first node. The remaining let us see in the next class. So remaining let us see in the next class.